right, folks, welcome back. We're going to take a look at units of concentration now. And before we actually take a look at units, we need to understand what concentration actually is. So the first thing that we're going to do is we're actually going to define the word concentration. All right, and concentration basically is the amount of substance that you can get into an amount of space. Okay, so essentially the amount of solute that you're able to dissolve in the amount of solvent is going to be the concentration. Okay, the more solute you have per solvent, the higher the concentration. The less solute you have per solvent, the less concentrated. We would actually also call that the more dilute. Okay, it would be more diluted. So the terms that we're going to use for this are actually molarity and molality. Okay, the first one we're going to look at is molarity. It says that molarity is the number of moles per liter of solution. And so these are our two formulas that we can use. Okay, right here the big M stands for molarity. N is our number of moles of solute, and L is our liters of solution. Now, if y'all remember from previous units, we don't very often give you the number of moles of a solution. Okay, I don't have a magic machine that says I can put some stuff on and say, oh, this tells you how many moles it is. Okay, I do have a machine, however, that can tell me the amount of grams that I have. So what we're going to give you most often is the grams. So for the most part, you're going to be using this formula right here, where molarity equals the mass divided by the molar mass divided by the liters of solution. Okay, and this situation right here, mass over molar mass, all that is N expanded. Okay, so this and this are um, the same exact formula. All right. The units that we're going to use is going to be moles per liter, or you can just put a big M, which represents molarity. Okay. So let's take a look at this first example. Okay. It says, let me erase this real quick. It says if 2 moles of potassium nitrate are dissolved in enough water to make a 1 liter solution, we would say that the concentration of the solution is 2.0 molar. We could also say that we have a 2.0 molar solution. Okay, so a 2.0 molar solution means that I have 2 moles of a substance for every 1 liter of solution. Okay, now if I had 1 mole in half a liter, that's still a 2-to-1 ratio, so I would still call that a 2 molar solution. Okay, so this next blank, it says molarity is the most common way of expressing concentration. An increase in molarity means that the solution has become more concentrated. Concentrated. And so that means that you just have more stuff per solvent. Okay, you've got more solute dissolved into your solution. I'm going to go ahead and erase this before I keep on moving. Okay, oops, let's get back to where we were. All right, so let's take a look at this first example here. It says how many grams of sodium hydroxide must be used to make a 500 milliliter solution of a 2.5 molar sodium hydroxide solution. Okay, so I know that my formula is molarity equals mass over molar mass divided by liters of solution. So let's see what all I have. Do I know my molarity? Yes, I do. My molarity is given to me in my problem. It is 2.5 molar. Do I know my mass? I don't. That's what I'm looking for. Okay, so I'm looking for my mass in grams. So that's going to be question mark G. Do I know my molar mass? Well, I'm dealing with sodium hydroxide, and sodium hydroxide's molar mass is 40.01. And the last question is, do I know my liters of solution? Well, let's be careful here because I know my milliliters, but I don't know my liters, okay? Now, I know that I can convert this by dividing that number by 1,000, and of course, that's going to get me zero point 0.5 liters, okay? So now all I have to do is just plug and chug right into my formula. So I'm going to change colors, and we're going to go 2.5 equals X over molar mass. Oh, I know my molar mass though, so let me go ahead and write that in. Okay, so I'm going to do X over my molar mass, which is 40.01, divided by my liters of solution, which is zero point 0.5, and now I just solve for X. Okay, so in order to solve for X, I've got X way up here, so I need to multiply both sides by 0.5. So I'm going to multiply by 0.5, and those cancel. Okay, now I've got 40.01 on the bottom, so I need to multiply both sides by 40.01. Multiply this side by 40.01, okay, and that gets 40.01 out from the bottom. And so now I have X equals 40.01 times 0.5 times 2.5, which should get me 50. When I type that into my calculator, that should get me 50 grams of sodium hydroxide. Okay, so the question now becomes, how would I make this if I were in a laboratory? Okay, what I would have to use is I have to use this little guy right here, which is called a volumetric flask. Okay, now a volumetric flask, this particular one is 500 milliliters. Okay, and there's a line way up here. There's the line. Okay, right at the top there. Okay, that line is where I'm going to fill my water up to. Okay, now let's think about this for a moment. If I fill this up with water at first, and then I try to add my solute, I'm going to have a problem, okay? Because then when I add my solute, I now have more solution than what I should have, okay? So here's what you're going to want to do to make this. Now, this is not sodium hydroxide, okay? This is copper 2 sulfate pentahydrate, which I'm going to use just to say that, just so that you can kind of see it on the camera, okay? So what I'm going to do is I'm going to mass this out real quick. Okay, so I'm massing this out. Oh, yes, there it is. Okay, perfect. 50 grams right there, okay? So now I'm going to dump my 50 grams into my volumetric flask. And there it goes, okay? 50 grams, there it is. So now what I want to do is I want to add some amount of water. Okay, so I'm going to go ahead and do that. Adding my water. There we go. All right. Now, here's the key. I'm not going to add all of my water at once because I want to make sure that I have enough room to stir, okay, so that I can get everything nice and dissolved, because if I fill it up, I'm not going to have enough room to stir at that point, okay? So I'm going to get this nice and dissolved, okay, there it goes, that looks good. And then I'm going to go ahead and fill it up the rest of the way, all the way up to my line, which I'm not going to do all the way because it's going to take me forever to get there, okay? So either way, you get the point. So then I'm going to fill this all the way up back to my line, which is going to give me a perfect 500 milliliters of solution, okay? So that's the idea behind making a molar solution. So let's get this erased. Okay, and let's take a look at one more quick example. The next example I want to look at is 12-29. It says if 40 grams of sodium chloride are used to make a solution whose molarity is known to be 0.5 molar, how many milliliters of solution do I have? Okay, well, what I'm going to do is I'm going to plug and chug into my molarity formula. Molarity equals mass over molar mass divided by liters. Well, I'm looking for milliliters. So what I'm going to do in the end is I'm going to solve for liters and then convert to milliliters. So I know that my molarity is 0.5, and that equals my mass of 40 divided by my molar mass. I'm dealing with sodium chloride, and I already know that the molar mass of sodium chloride is 58.44 divided by my number of liters, okay? Once I do all of this math, I find out that my number of liters equals 1.37 liters. Well, is this my final answer? Of course it is not, okay? The reason is because I go back and I find out that my problem wants to know how many milliliters did I have, okay? So what I need to do now is I need to multiply this number by 1,000 to get my milliliters. So therefore, I'm going to end up with 1,370 milliliters. Okay, that's going to do it for molarity. We'll take a look at molality on the next video. Go ahead and practice on this. If I were you, I would do the problem that was right above there just to make sure that you know how to do it. Okay, we'll take a look at more of this stuff in class. Thanks.